Some regions are preparing for its wrath, while others are already dealing with its aftermath. It is often blamed for drought and wildfires in Australia, floods in California, strong cyclones in Polynesia, and failed rice harvests in Southeast Asia. As you may have guessed, today we're going to dive into the heart of a strange anomaly. El Niño, the terrible child of the climate, is back, and we're going to be hearing about it all over the planet. But before we start wondering if it's really reasonable to blame everything on it, let's begin by looking at the birthplace of El Niño. Here you are at the level of the tropical Pacific. In this region of the globe, under normal conditions, the winds invariably blow along the equator from east to west. And in doing so, these gigantic moving air masses, called the trade winds, push the warm surface waters toward the western Pacific. Thus, under normal conditions, surface temperatures commonly exceed 28 degrees near Indonesia. On the equatorial shores of Peru and northern Chile, sea temperatures are about 7 to 8 degrees lower than the average for that latitude. This cold current, which bathes much of the Cordillera's coastline, originates from the strength of the trade winds, which, by driving away the warm surface waters, allow the colder waters to rise from the depths. A self-sustaining mechanism relies on the large temperature and pressure differences across the Pacific Ocean to maintain strong trade winds. But when El Niño, the child in Spanish, awakens, for reasons still not well understood, the conveyor belt of winds slows down and the climate system breaks down. The immense masses of warm water that used to accumulate in the western Pacific are no longer held there by the strength of the trade winds and gradually move closer to the coasts of the Americas. Or, in a kind of vicious circle, their presence further weakens the strength of the winds, while the cold surface waters return to the depths and thus further accelerate the movement of warm water toward the east of the vast ocean. This variation in the ocean temperature by a few degrees may seem trivial to you, but these local disturbances will quickly have absolutely global repercussions. Consider that El Niño can, in just weeks, single-handedly alter the dynamics of an ocean current 1.5 times Europe's size. The energy in these massive moving warm water masses will disrupt atmospheric circulation, temperature, and humidity. Gigantic tropical clouds, which can rise up to 16 kilometers above sea level, then form in places where they are usually absent, and their imposing presence goes on to alter atmospheric circulation. In certain places, air currents are born, others weaken, shift, die, or reverse. By distorting the structure of the winds, El Niño changes rainfall patterns, dries out regions that are usually subject to heavy precipitation, shifts the position of monsoons, and alters the usual paths taken by typhoons. And so these disturbances, which were initially localized in the tropical Pacific, end up having a cascading impact on the global climate. So we can see the El Niño event as the fall of a series of dominoes, with the first to fall always being the wild child of the Pacific. Since last July, meteorological agencies worldwide have closely monitored El Niño and unanimously agree on its developments. After several years of dormancy, 2023 is definitely the year of its awakening. So, concretely, what will the end of 2023 and 2024 look like? Do we know how the child's tantrums will impact the affected world regions? Let's examine the typical effects of El Niño in different world regions. El Niño significantly disrupts the climate across the entire equatorial Pacific. Along South America's coasts, rising surface water temperatures increase humidity and greatly intensify rainfall, often with severe consequences for these typically dry regions. Thus, during the Super El Niño of 1997-98, the coastal desert of Peru was hit by torrential rains, receiving in just a few days nearly 16 times more water than in a normal year. The ground, unable to absorb such large amounts of water, was washed out, and devastating floods and thick mudslides left 250,000 people homeless. And while one part of the world suffers from too much water, another is drying out. Because while in one part of South America, deserts are regularly flooded by torrential rains, on the other side of the ocean, usually humid rainforests can suffocate under a merciless, scorching sun. In India, the classic impact of El Niño is a delay in the monsoon season. And we can expect intense periods of drought to hit Australia and Indonesia, bringing with them devastating forest and bushfires. For the last 100 typhoons, anomalies have diverted them from their usual paths, called climate alternative. By disrupting upper atmospheric dynamics, El Niño can shift the fast-moving, high-altitude windless zones known as jet streams. Thus, in North America, during El Niño phases, the polar jet stream is pushed further north by low Pacific pressures, resulting in hotter and drier summers than usual across much of the northern part of the continent. The thousands of forest fires that ravaged Alberta, Ontario, and Quebec this year remind us of their scale, partly due to the Pacific's terrible children. And if the shift of these polar jet streams northward tends to make the winters in this region milder, the intensification and southward shift of subtropical currents make winters in the southern United States more unsettled, cool, and rainy, increasing storm strength in states like Texas, Florida, and California during El Niño. Elsewhere, on the other side of the world, El Niño often squeezes the clouds over much of eastern Horn of Africa. But this picture is only broadly accurate, and it's important to remember El Niño's effects are never guaranteed. For example, during the terrible El Niño of 2016, Ethiopia was strangely hit by one of the worst droughts in the country's history, during which more than 10 million people needed emergency food aid. Finally, even regions as far away as Europe or the Mediterranean basin, which might at first seem to be spared, are not really unaffected. Because even here, statistically, in the years when El Niño strikes, winters become drier and colder in the north, heat waves tend to be more frequent, and the Mediterranean basin is slightly wetter at the beginning of autumn. El Niño's arrival also brings some unexpected indirect effects. In fact, it has been observed all over the world that there is an increase in certain types of epidemics following its appearance. As a result, this year, the World Health Organization fears an increase in malaria, dengue, and cholera. Okay, so do we know how strong the 2023-2024 El Niño will be? Predicting the weather months ahead is likely one of the most complex fields. But we still have a lot of clues and many prediction models to talk about it. El Niño has its greatest impact on temperatures and precipitation during the Southern Hemisphere's summer. And the phenomenon should, as it almost always does, intensify throughout the fall, after which the climate disturbances should subside in the spring. Because El Niño usually lasts for 6 months to a year, unless we are at the beginning of a super El Niño phase. And in that case, it could last for 18 months as super El Niño. Now, I think I need to explain, even if it's a bit worrying. To judge the intensity of El Niño, scientists measure how much the surface temperatures of the ocean in certain areas of the Pacific Ocean along the equator are warmer or colder than the normal average. In fact, it has been observed that the more this oceanic index deviates from the average, the more intense the phenomenon is likely to be. By the way, in order for us to start talking about an El Niño phenomenon, the temperatures need to be at least half a degree warmer than normal for a given month, which happened last July. In this table, you can see all the values of the index measured since 1950. Past El Niño events are in red, and you can see the upward trend this year, where in just 4 months, we went from 0.5 degrees Celsius above average to 1.3 degrees Celsius. Currently, the 2023 El Niño is considered moderate, except that we are still in an upward phase, and almost all models predict that in the coming months, this index will continue to rise, reaching between 1.8 for the most optimistic and up to 2.4 for the most pessimistic by the end of the year. That could match or even exceed the past 4 super El Niños. To give that superlative to a climate troublemaker, the equatorial Pacific's surface temperature must be at least 2 degrees Celsius above its normal average. And now, you might be thinking that an extra half a degree isn't the end of the world. So, the amount of energy transferred from the ocean to the atmosphere during a super El Niño is roughly equivalent to 100 times the total annual energy consumption of all humanity. I'm not going to give you a laundry list of the climate disasters that have shaken our planet during the last 4 super events. I think you can easily imagine their ability to amplify effects that are already intense during a regular El Niño. The first thing is that the warm phases we've entered since July come after 2.5 years of a cold period. It's important to understand that El Niño events alternate with normal phases, but also with phases of cooling of the surface waters of the tropical Pacific Ocean. Called La Niña, this phase is characterized by stronger trade winds and a slight decrease in average global temperatures, While most El Niño phases last 9 to 12 months, the last one lasted nearly 2.5 years. 2.5 years during which the large amount of cold water rising from the depths of the South Pacific slightly reduced the effects of atmospheric warming. Still, even with this relief valve, 2020, 2021, and 2022 were among the hottest years ever recorded. The second anomaly comes from the fact that this year, almost all of the world's oceans had already reached record surface temperatures. And this, even before El Niño had begun. You can see here the daily average surface temperatures of the world's oceans in 2023, which, since early April, has by far been the hottest year recorded in the past 40 years. Now consider where 2016 stands, the year of the last Super El Niño, which remains so far the hottest ever recorded across our entire Earth system. In short, 2023 is, if I may say so, well on its way to dethroning 2016. According to the European Copernicus Observatory, this year we are even on a trajectory of global anomalies of more than 1.4 degrees compared to the pre-industrial era. Add to this the fact that each El Niño event brings with it a rise in global annual temperatures of about 0.1 to 0.2 degrees on average. And you can see why some people think that 2024 has everything it needs to take first place in turn. Some models predict that next year could see a temporary crossing of the 1.5 degree warming limit, the most ambitious goal of the Paris Climate Agreement. In 2024, the world may get a brief glimpse of what lies ahead in a few decades. Beyond this rather bleak picture, we must keep in mind that El Niño also carries a duality, bringer of climate chaos. The climate's enfant terrible can sometimes bring good news to certain areas. In every turmoil it causes, there is always a little melody reminding us that this devastation can, on the other side of the globe, mean a blessing. For example, while it promotes hurricane formation in the central and eastern Pacific, El Niño usually reduces their number in the southern Atlantic and Gulf of Mexico, which is somewhat pleasing when you live in the Caribbean. Well, the downside is that, on the other hand, during strong La Niña events, the Atlantic experiences much more severe tropical storms overall due to greater atmospheric instability in the southern Atlantic. To illustrate how the negative can actually contain some positive, I need to tell you a little story, the story of how it got its name. The term El Niño probably appeared in the 17th century in Peru, where it was used by fishermen to refer to the arrival of a current. The water was unusually warm for their typically cold region during Christmas, hence the term El Niño in reference to the baby Jesus in Spanish. At the time, fishermen saw these warm year-end waters as a blessing, bringing a more diverse catch with tropical species like sea bream, tuna, and shrimp. And it was only later that El Niño would gain its bad reputation, and the angel would turn into a demon. Already in this region, at the beginning of the 20th century, people started to keep a wary eye on the phenomenon, because by increasing rainfall, El Niño regularly disrupted the harvesting of bird droppings. The rains would regularly wash away the piles of accumulated guano, which was then widely used to produce fertilizer. At the same time, the arrival of warm currents puts an end to upwelling, those rises of cold, nutrient-rich water that allow plankton to thrive, as well as the fish that feed on them. In Peru, the fishing industry, now the fourth largest gross domestic product contributor, relies heavily on anchovy exploitation, a species thriving in these large cold currents. As a result, starting in the 1950s with the increasing share of industrial fishing mainly focused on anchovy exploitation, the arrival of these warm waters drastically reduces both the populations of small oily fish and a part of the economy. El Niño is clearly seen as a calamity by Peruvians. Although this powerful phenomenon partly causes periodic fish stock collapses, it conveniently distracts from the ongoing devastation of overfishing in discussions. In short, today, the term El Niño no longer refers only to the warm currents coming down to Peru during the Christmas season. Because by connecting together a large number of seemingly unrelated events, we have been able to uncover a phenomenon of exceptional scale and dimension. An old phenomenon. Since 1900, there have been at least 30 El Niño anomalies, recurring every 2 to 7 years on average. Thanks to the study of fossil corals around the Pacific Rim, it has even been shown that these southern oscillation phenomena have occurred at regular intervals for at least 130,000 years. Today, around 4,000 Argo buoys and hundreds of thousands of measurements taken by satellites and ships closely monitor water temperature, wind, and pressure variations, allowing us to take the pulse of these capricious children in real time. By carefully analyzing all the accumulated data, we are able to confirm that the end of this year and much of 2024 are likely to experience climatic conditions that are extraordinary in the sense that they deviate from the norm. Coming from the depths of the cold waters of the Pacific, the awakening of El Niño is like a cry, a call to awareness, reminding us how, on our Earth, climatic phenomena know no borders. El Niño and its less publicized counterpart, La Niña, act like lungs that shape and strengthen climate rhythms. Orchestrating a dance of currents and winds, it commands the elements and decides whether deluges of rain or sunshine will fall from the sky. After these disasters, a great unknown remains. Do El Niño and global warming create a dangerous combination? In the future, will the surplus energy contained in the ocean and the air increase the frequency and strength of these phenomena? We can only be fairly sure that El Niño and La Niña will keep occurring, driving climate upheavals on our planet. We are reminded that despite our arrogance, nature, in all its splendor and fury, firmly holds the reins, turning the fluttering of butterfly wings into the beating of dragon wings on the other side of the globe.